Supporting offline updates is, well, it's really cool, but there are some inherent risks to this model. Now, up to this point, we haven't seen any problems because we haven't turned on support for conflict resolution. So as a result, every change made simply overwrites the server's copy indiscriminately. We don't even know when we have collisions. And the problem is, once we activate the built-in conflict resolution support, all of these collisions or conflicts will result in a client-side exception. But there's actually a good thing, because then we'll know we've got a problem, and Azure sends us all the details that we need so we can decide what to do about it. So let's look at the process of resolving the conflict. To turn on the automatic conflict resolution, all you need to do is add the version property into your DTO. Now this is just a system column. And the reason that Azure doesn't notice the conflicts is because we're not sending the version with our updates. We're only sending the required fields. Now by mapping this column into our data transfer object, we capture it as part of our data and can then send it back to Azure when we make a change. Then Azure can compare this column, which changes each time someone updates the row, against the server-side version. And if they're different, it notifies us about the conflict. Now, when this happens, the Azure service will return an HTTP error response as a result of the conflict, returning both the client record and the server record. The client SDK will turn this error response into a .NET exception, which your client code must handle. Now, the exception type is a mobile service push failed exception, and it will contain all of the failure details for all of the conflicts that have occurred as a result of the last push. Now, inside this exception is a list of table errors. Each one describes a single update failure. And the client must walk through this list and decide what to do for each conflict. Now, each conflict error is represented by a mobile service table operation error. This object contains the details about the conflicts as well as both the client and server DTO, so you can compare and decide what to do. So here's an example. We walk through each error and call a custom method to resolve each conflict based on the error. Now notice that our custom method is async, and this is because the response to a conflict will often involve sending the server another update by merging the client and server record, or by simply replacing the server record with the client's version. Now this means, of course, a network round trip. So we tell the server what we want to do by calling a method on the mobile service table operation error. Now once you detect a conflict, you've got a variety of ways you can handle it. You can decide that the latest update is the correct one, right? So the last one in wins. You can tell the user and let them pick the version they want, push it back to the user. You can try to merge the two, or again, have the user do it. Or finally, you can decide that the server is always right. Maybe the server is the source of truth, and if we conflict, then we lose. And the mobile service table operation error object includes 3 methods on it for selecting each of these options. We have the cancel and discard item async method. So this is going to get rid of your local changes and revert back to the initial version. We have cancel and update item async. This again throws away the local changes and updates to the server version. And finally, we have the update operation async method. And this is going to update the local version with a new version, and then it'll resynchronize with the server. So here's an example resolution method. In this example, we assume that we always want the latest client version to be used. So let's see how this works. First, we take the server and local item and we compare the custom fields. And we're ignoring the version and the update data information. Now, if they are the same, and I mean that by are the same logically, not the same reference, then we can ignore this conflict. The other client made the same change, so we can call cancel and discard item async. And in this example, we're comparing the text property, but you could have a more rigorous, a more complex check for equality as well. Now, otherwise, we'll take our version over whatever the server has. So we need to copy over the version data and then resubmit our changes to Azure. And this will also update our local object in our database.